It may seem improbable, but there is an IBM Master Clock inside this case. The case is smaller than a briefcase. It's only 16 by 10 by 6 inches. But inside is a fully operational demonstration master clock that a salesman could use to explain the operation of the IBM Master Clock, and most importantly, demonstrate the remarkable and unequaled IBM self-regulating slave clock correction feature. A partial dial is used so the customer can see the timing of the correction. Okay, if it's an operating master clock, where's the pendulum? Certainly there's no room for a pendulum in the case, so instead a balance wheel escapement is used. I've temporarily removed the demo dial to show the balance wheel escapement. The escapement closes the contact every minute, advancing the slaves 1 minute and winding the mainspring. All the contacts below the minute contact are used in the self-regulating correction feature. The case contents include a cord to connect to 120 volt AC current, a 60-beat IBM electromechanical self-winding master clock movement, a transformer to provide 24 volts AC, a rectifier to convert 24 volt AC to 24 volt DC, and a relay to carry the 24 volt current each minute to rewind the movement and advance the two slave clocks. This salesman sample was originally used in the UK and has been converted from 240 volt 50 cycle to 120 volt 60 cycle current. I am tipping the slave clock door to show the slave movements. They each advance as they receive the 24 volt DC pulse from the master clock. The slaves have 3 wires, making the self-regulating feature possible. Certainly a potential customer is interested in a master clock that reliably advances the slave clocks each minute. An IBM Master Clock does that beautifully. But what about when there's a power interruption? The slave clocks will fall behind and need to be synchronized. This is where the sales pitch gets more interesting and the IBM system shines. At the 59th minute of each hour, the IBM Master will correct slave clocks that are up to 10 minutes fast or 17 minutes slow. I have the 2 display clocks behind, but not equally behind. The self-regulating advanced contacts transmit a pulse every 2 seconds to the slaves until they reach the 59th minute. The inset video shows the 2-second contact in operation. The customer can see the slaves that are behind accept the 2-second pulses until they reach the 59th minute. When the slaves reach the 59th minute, they wait for the next minute pulse on the hour, and the clocks are absolutely correct. I have another video that explains this correction feature in detail. There's a link at the conclusion of this video. This salesman display can make a very sophisticated synchronized clock system seem understandable. Anyone responsible for maintaining the synchronization of all systems clocks would have a much simpler life with a self-regulating clock system from IBM. The self-regulating system was introduced by IBM in the late 1920s and remained the finest in the industrial time industry. Thank you for watching, and please give a thumbs up if this was helpful. Subscribe to my channel and click the notification bell if you wish to be notified when I post more vintage electromechanical clock videos. Thanks again.